Okay, so take a minute and write the date and the title down for our notes here, functional notation. We've talked about this a little bit before in that when you have something that looks like this, it's the same thing as y equals 6x, right? And we've talked, this is called f of x, and f stands for the function of x. Okay? So when you see this, it can be written as f of x equals 6x. Okay? Now, we should also recognize this is in slope-intercept form. Y equals mx plus b. And you can see that my slope, which is the m, slope, is 6. X is in the x spot. And you can see there's nothing in this b spot. So we assume it's 0, since 0 is nothing. And remember, this is the y-intercept. Okay? So looking at this equation, if I want to graph it, I know that the y-intercept is at 0, so I can put a little point here. And then the slope is the whole number 6, or 6 over 1. So let's do that, 6 over 1. And if you remember from last year, this is how much it can rise, and this is how much it runs. So remember, rise is how far it goes up on the y, and run is how far it goes over on the x. So here I can tell it's going to go up 6 on the y, 1, 2, 3, 4, 5, 6, and then it's going to go over 1 on the x. I don't really like this rise over run because I think it's sort of confusing, but because if you remember this is 6, or excuse me, y over x, it's a positive 6, so it goes up 6. It's a positive 1. This is the positive direction on the x, so it goes 1. And then we can draw our line from there. And I've kind of learned not to try to draw my own lines because they never really turn out as lines, right? And then I can just put in some arrows because it goes on forever. So this is this equation, f of x equals 6x, or y equals 6x. Now when we're talking about functional notation, we're talking about what you put in for y here. Now this is also called the output, and the x is called your input. So we're talking about functional notation, we're talking about what you put in and what you get out. So looking at this equation, f of x equals 6x, let's say I want to know what this function will be for f of 2. So you can see the 2 is in the x place. So to find out what f of 2 is, I very simply replace x with 2. So f of 2 equals 12, right? Or we could say that would be that would be when we plug 2 in for x, the y, or the output, is 12. Okay? So I could ask for what is f of negative 3. So I go back to my equation here, 6x, and instead of x, I'm going to plug in negative 3. So what this means is when I plug in negative 3, I get negative 18. So therefore, when the input is negative 3, my output, or my y, will be negative 18. Okay, so let's look at another example. So here, again, we have an equation. So again, I had to write it in functional notation. I would put f of x, because it's a function of x, equals 2x plus 3. Okay, so remember this is called functional notation. And going back to my graphing, if I needed to graph this function, this is y equals mx plus b. So this is my y-intercept, meaning it's going to go through the 3 on the y, which is here. This is my slope, so that means it's 2 over 1. So it means I need go 2 on the y direction and 1 in the positive x direction. Ugh, that looks terrible, sorry. Let's try that again. It's not easy to write on this. All right, so from this point, I'm going to go positive 2 in the y and 1 in the x, okay? And then we can just draw that line. So going back to our slope-intercept, okay? And do our little arrows here. So there we go. So here's my function of x. Here's my line, okay? So if I want to know, here's my functional notation, I want to know what f of negative 1 is. Like before, we'll plug negative 1 in for x. So when the function is of x is negative 1, we'll have negative 2 plus 3, or 1. So again, when my input was negative 1, my output, or my y, was positive 1. So remember, this is your input, or your x, and this is your output, or your y, because that was the solution to the input. And if you look here, that is a point on that function, so it totally works, right? So, oops, hello, what happened? Sorry. So if I wanted to know what the output is for f of, let's say, negative 11, then we would put 2 times negative 11 for x plus 3. And so it would give me negative 22 plus 3, or negative 19. So when x is negative 11, my output, or my y, would be negative 19. And if we look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, around here, it would be probably down here, which looks like it's in line with the function. Okay? So a couple things. You need to know how to graph in slope-intercept form. You need to understand this is functional notation. You need to know that y equals is the same thing as f of x. And you need to know how to plug in for f of x to get the output, the input and the output. So if I look at this one, and I say I want to know what f of negative 9 is, we're very simply going to rewrite this equation, but instead of x, we'll put negative 9 over 3. So then we'll have f of negative 9 equals 5 plus, and then that becomes negative 3. So f of negative 9 gives me a positive 2. And then if I wanted to write it as a coordinate, it would be 2, negative 9. Okay, so we're going to do a little bit with that, some practice here. So here's your example. I would like for you to find out f of negative 2. And look at your choices to the side. Here, I would like you to find out what f of negative 52 is. Here, I would like for you to find out what f of negative 55 is. Ooh, and this one would be a little tricky one. Here, I would like for you to find out what f of negative 1 is. So remember, you have to plug that in for both x's here. See how you do with that. That'll be our challenge question, and we'll stop there. Have a great night. We'll see you tomorrow.